How specialized lighting reveals invisible damage in inspection. Imagine trying to find tiny cracks or hidden corrosion on a metal surface. Standard light might not show these flaws clearly, but specialized lighting can make them stand out. This technique is a game changer in failure analysis and investigative work. When inspecting products or machinery, it's often the smallest damage that causes big problems later on. Using the right type of light helps inspectors see what's normally hidden from view. Different lighting methods are used to bring out these subtle issues. Directional lighting involves shining light at angles that cast shadows in cracks or dents, making them easier to spot. Diffused lighting softens the light to reduce glare, helping reveal faint discolorations or surface irregularities. Ultraviolet light causes some materials to fluoresce, highlighting cracks or contamination invisible under normal light. Infrared or thermal imaging detects heat patterns that indicate internal damage or friction, even if the surface looks fine. Polarized light reduces reflections, making stress fractures or coating flaws more visible. In failure analysis, these lighting techniques are used across many fields. For electronics, they help find cracks in solder joints or corrosion on circuit boards. Mechanical parts like engine components or structural beams are inspected for surface cracks or weld flaws. Medical devices are checked for tiny scratches or contamination that could affect performance. In aerospace and automotive industries, critical parts are examined for fatigue cracks or surface wear before they cause failures. The main advantage of specialized lighting is that it makes defects much easier to see than with just the naked eye or regular lighting. It's also cost-effective because it doesn't require expensive equipment like microscopes or X-ray machines. These lighting methods are versatile and can be used on many different materials and products. They give immediate visual feedback, helping inspectors make quick decisions about whether a part is safe or needs repair. However, proper setup and training are essential. Incorrect lighting angles or intensity can create glare or shadows that hide defects instead of revealing them. These techniques mainly focus on surface damage, so internal issues might need other methods like ultrasonic testing or X-ray imaging. Environmental factors such as dust or moisture can also interfere with lighting effectiveness, so inspections should be done in controlled conditions whenever possible. In failure analysis, specialized lighting is a key investigative tool within visual inspection. It helps uncover damage that might otherwise stay hidden, giving clues about how and why a product failed. By carefully choosing the right lighting technique and angles, inspectors can see tiny cracks, corrosion, or contamination that are critical to understanding the health of a component. This approach allows for faster diagnosis, better maintenance decisions, and ultimately, more reliable products.